We're on page 79, topic 15, and the exercises that we're going to do from here are 1E and 1F. From number 2, we're going to do L and O. So L and O from number 2, and from number 3, we're going to do part B and part D. So 79 1E, evaluate each fraction for x equal -2 and find the values of x for which each fraction is undefined. So first thing what we do is evaluate the fraction when x equals -2, and we take the original expression everywhere that x appears, we replace it with -2. So in this particular case, -2 cubed is -8. 7 times -8 is -56. Here, x squared is -2 squared. -4 times -2, replacing the x with a -2, -5. So the denominator is 4 plus 8, which is 12. 12 minus 5 is 7. We said that the denominator was -56, so the answer is -8. Now the next part of the problem says we have to find what values of x for which the fraction is undefined. Now this fraction here, this fraction will be undefined when the denominator is 0. So we're really asking what values of x make the denominator 0. For what values of x is the denominator 0? When the denominator is 0, the fraction is undefined. So we set the denominator to 0 right here. Factoring gives us x minus 5 times x plus 1. First times first gives me x squared. Minus 5 times plus 1 gives me -5. I have minus 5x as the inner and plus x as the outer, and that sums to -4x, so that's correct. So now I said x minus 5 equal to 0, and x equals 5. And I said x plus 1 equal to 0, and then in that case x is -1. And I check both the values, the x equal to 5 and the x equal to -1 here. Check the left side of the fraction. X squared minus 4x minus 5. X squared here will be 25. 5 squared is 25. Minus 4x is -4 times 5 is -20, and this -5 is that here. So here we have 25 minus 20, which gives us 5. 5 minus 5 is 0. The right side is 0. So that's a valid value. And now I'm going to check that the x minus 1. If I substitute in for x squared when x is -1, I get 1. Minus 4 times -1 gives me +4. And then the -5 goes over here. 1 plus 4 is 5. 5 minus 5 is 0. The left side is 0. The right side is 0. And the two are equivalent. Now here we're doing the same thing. We're evaluating the fraction for when x is -2, so I'm going to replace here in the first part of the problem, I'm going to replace x with -2. -2 squared is 4. 4 plus 1 is 5. So the value of the fraction will be 1 when x is -2. Now, as far as the second part of the problem is concerned, for what values of x is this fraction undefined? In order for this to be undefined, x squared plus 1 has to equal 0. But we can't solve this. If x squared equals minus 1, there's no solution for that. If x squared equals minus 1, it can't be x equals 1 because 1 squared is 1. And if we choose minus 1, minus 1 squared is also 1. So there's no value, at least what we call a real number value. There are other ways of doing this, but it's beyond the scope of this course. So there are no values of x for which this is, this will be undefined. Okay, now we're going to 2L. We want to simplify this problem. And I look at this and right away I can see that there's a possibility of factoring out numbers and variable term here. So from the numerator, I can factor out 3x because the highest number that will go into both 3 and 12 is 3. Here I have x cubed, and here I have x to the power 1. I always choose the lower one. 3x times x squared gives me the 3x cubed. 3x times minus 4 gives me the minus 12x. And now, as far as this is concerned, I can take out the number 6 from the denominator. 6 goes into 6 and 24. Take the lowest power of x, which is x to the power 1, or just x. I can factor out 6. 6x times x squared gives me 6x cubed. 6x times minus 4x gives me minus 24x squared. And 6x times plus 4 gives me 24x. Now I can factor this, and I can factor this further. So this is the difference in squared. There's no middle term, x plus 2 and x minus 2. This is a perfect square, x times x. And here we have minus 4x plus 2. I can only factor that as minus 2 and x minus 2. So this is x minus 2 squared, if you like, which is equivalent to this. Now just to go back to here, I said this was the difference of squared. You'll notice that the inner term plus 2x is canceled by the outer term. There's no middle term here. Here there is a middle term, so both terms have to be identical. It can only be minus 2. So you'll notice x times x here gives me the x squared. The minus 2 times the minus 2, the last term, gives me plus 4. The inner is minus 2x, and the outer is minus 2x. We combine them to give us minus 4x. Now you can see I can factor out the common terms are x. I can cancel this in the numerator with this in the denominator, this in the numerator with that in the denominator, and then just divide 3 into 6, and I get 2. And I'm left with x plus 2 and x minus 2. So you'll notice, for example, I've indicated that 3 over 6 reduces to 1/2, which is essentially here there's an implied 1 or 2. So you can realize that 3 over 6 is 1/2 if you want, and then just remove the 1. Or you can just say 3 into 6 gives me 2 and just put the 2 down there. So here, in this case, we're going to factor by grouping. So we're going to take these first two terms, and if you look, and then we're going to take these two terms. So this is just this rewritten. I've just rewritten this. So let's see, out of these two terms, what is the common term? I can take out y. Y times x squared gives me x squared y. Usually we write this alphabetically. It doesn't matter if you write yx squared here, so it's okay. Y times x squared gives me x squared y, and y times plus 1 gives me plus y. Now, out of these two, I can take out the number 5 as a common factor. 5 times x squared gives me 5x squared, and 5 times plus 1 gives me plus 5. Now, on the denominator, I'll factor out the x, and I get x5 times x gives me 5x, and x times plus y gives me xy. And right over here, this bracket shouldn't be here. It should not be here, so it's just an error. I added an extra bracket, and that should not be here, so don't worry about that. I've corrected it over here. So now I cancel like terms, and 5 plus y is the same as y plus 5. So I'm canceling this, and I have x squared plus 1 over x right here. Now, you'll see that over here, I'm just going to interchange. I'm going to rewrite the problem. So I've rewritten this here, and I'm going to get this here so that this term goes here and this term goes there. So I've interchanged the second and third term, and you see now I do factoring of the first two here. I can take out x squared from these two terms. So I factor these terms. X squared times y gives me x squared y. X squared times plus 5 gives me 5x squared. So now I have y plus 5 and y plus 5, which are common. Okay, so when I factor that out, I'm left with x squared plus 1. Because there's an implied 1 here, the only way that I'm going to get y plus 5 here, if I multiply y plus 5 times plus 1, that's how I get y plus 5 here. So now I factor this, and this obviously factors to this. I can take out the x here and get 5 plus y. Now I can factor this, and I get x squared plus x over x. Now the reason I'm doing this is to show you that even though I may alter the grouping, I get the same answer. And that often happens. You're often able to do that in these kinds of problems. Now here I'm asked to multiply and simplify, and you'll notice a difference here. This is multiplication. So when I multiply this, I can multiply the numbers. 9 times 6, I get 54. Y squared times y gives me y cubed, and I'm just left with x. I multiply the denominator here. 18 times 3 still gives me 54. And I've got the y cubed. I'm lining up the y's, and I've got x squared. So now the 54's cancel, the y cubed cancels. I get x over x squared. I can just bring this down, and I have 2 minus 1, because this is an implied 1 and this is 1 over x. Usually when we do that, you say, well, why don't you bring this up and say 1 minus 2 and put the answer as x equals x to the power minus 1. Usually we leave the powers as positive. And so that's why I bring the 1 down here and subtract it, because the power here is positive. Okay, so now, again, this is a multiplication. And if you look at each one of these, you can see that you can factor each one. For example, here I know I can factor 5 out of there. Here I know I can factor 3. Here I know I can factor 4. Here I know I can factor 6. So after a while, you begin to recognize. So instead of 5x minus 15, I've written 5 times x minus 3. Instead of 4x plus 12, I've written 4x plus 3. And instead of 3x plus 9, I've written 3 times x plus 3. Instead of 6x minus 18, I've written 6x minus 3. Now, the x minus 3, the blue lines cancel. The x plus 3 cancel. I've got 5 times 4, that's 20. 3 times 6 is 18. Now, if you left it like this, you haven't reduced it as much as possible. And you may remember that I stressed, when you get to the end of the problem, ask yourself, can you reduce that even further? Well, I can divide 2 into this number, and I get 10. And I divide 2 into this number, I get 9. So there's a common factor 2 for these, and this reduces to 10 over 9. So that completes the problems that we're going to do on page 79.